Okay, so today we're going to begin with the course of the organic chemistry that is for A2 students. This is the outline which is being taken from the Cambridge course, Cambridge International. And it talks about what? It tells you that the topics that will be included in the organic chemistry for A2 chemistry would be introduction to A level organic chemistry, then hydrocarbons, halogen compounds, hydroxy compounds, carboxylic nitrogen polymerization, or organic synthesis. It's more like AS chemistry, but of course, there will be some modifications, some deductions, and some new things as well. Beginning with how does it look like or what introduction is all about. The first thing first that you need to understand, it's all about the chemical compounds or maybe the functional groups which differentiates the compounds from one another, and that helps to create the organic different families or homologous series, what you say also. You can go through my AS chemistry lectures and you can see the basic definitions that are very important to be a part when you are studying the organic chemistry. So first thing first is Arenes. That's the structure looks like. I'm not going to go into the details a lot because we will be studying this in more detail later on. Halogenarenes, phenols, acyl chlorides, amines, amide amino acids, these are the compounds, all of these structures that are included in your course, and we'll be doing it in detail as well. Then comes the first topic, which is when you will be studying or you will be going through the introduction, then what are the things that you're supposed to learn? Again, the learning objectives are extracted from the syllabus of Cambridge International. Then you need to understand the compounds in the table on page number 47, that the one I've shared with you previously. You need to know how to interpret and use the general structure, display, and skeletal formula of the classes of compound. Then you need to understand their nomenclature. You need to understand their chemical and physical properties as well. So quickly beginning with arenes. This is the first homologous series that you were going to study. So arenes are what basically? Arenes are the aromatic compounds that contain a benzene ring, but then comes in mind that what benzene ring is. So it's basically a 6-carbon compound family or a compound where 6 carbons are joined together to form a ring-like structure, and that is called benzene ring. And the best part is it has double bonds, the pi bonds on the alternative positions. This can also be considered as a benzene structure. These double bonds can be shifted to different positions. So this can also be considered as the arranged structure, or if you draw it like this, please excuse my drawing, but if you draw like this, even all of these structures will be considered as what? The benzene structures. Again, I'm telling you that the organic compounds, they differentiate from each other on the basis of one thing, and that one thing is called the functional group. And what this functional group is, this functional group is basically, can be an atom, it can be group of atoms in an organic molecule that will tell you the characteristics and the physical properties of the compound. I should write it over here as well. That tells you what? That tells you the characteristics plus the physical properties. All right. So moving ahead, now specifically what you need to learn, I always tell my students to put a star on the topic where you feel that or where you know that you need to learn these topics. See, it's always knowledge that you remember, then it also the concepts that you understand and that help you to analyze the other things as well, situational concepts specifically. Then there are questions that you need to solve. There the problem solving skills are also required. So as far as this is concerned, these chemical properties is better to learn them. Okay, so what chemical properties can be there? First of all, as I said earlier as well, so it's a ring. Ring means that it has this these double bonds on their alternative positions. Since these double bonds can be shifted, here there are different positions. Here there are different positions. So this ring determine what that they are delocalized electrons that can shift from one position to another position. So this can be considered as the first chemical property that we say what that due to the delocalized, and what exactly is being delocalized is the pi electron system. So because of the delocalized pi electron system, these compounds are electron rich, of course. So if they are electron rich, then what kind of attack they undergo in organic reactions? If you are good in gas chemistry, you should know that whether these are electrophiles that we're going to attack the compounds, or maybe they will be the nucleophiles. Now, what electrophiles are? Electrophiles are the electron deficient ones, the one which get the positive charge, and what nucleophiles are? Nucleophiles are the electron efficient ones which get the negative charge. So if there is a compound which is rich in electron, means that is rich in the negative charge, that means the feature that we're going to adapt that organic compound for further chemical reaction would be an electrophile, because electrophile has a positive charge, and the negative charge or the negative atmosphere around the compound will going to attract that positive charge. Okay, so what do we say? What would be the next property? The next property says that arenes undergo electrophilic attack. But it has to be under right conditions. Conditions are really important. Under right conditions. Okay, there's another thing that is really important to understand. I would change the color of the pen so that you should know that it is important and you need to learn it, because that we're gonna be shared or discussed at multiple times later on. See, this can be considered as a third property as well. This delocalized electron system brings something, which is what? Which is stabilization, right? So this delocalized electron system brings stabilization, and this stabilization, of course, reduce the reactivity. I always tell people that chemistry is all about the life sciences. The more unstable you are, the more reactive you are going to be. The more unstable the elements would be, the more reactive they were going to be. They would be required to undergo a certain reaction, because an element can't survive without stability. So when stability comes, then they are in their comfort zone. So they reduce the reactivity, and that is why this makes arenes, I repeat, this makes arenes resistant to the addition reaction. That is very different to alkenes. So in the next step, of course, the AS chemistry we're going to be involved, and those concepts can be asked in terms of doing the comparison of the AS chemistry compounds to the A2 ones. Like you must have studied alkenes. So if we see alkenes, in alkenes, the carbon-carbon has a double bond. And of course, this double bond positions the slavers or the compounds you studied got between two carbons only. And if we talk about arenes, in arenes even the carbons have double bond, right? The carbon present over here, the carbon here, the carbon here, the carbon here, the carbon here. All these edges, the carbons are present. So double bond here as well. So if we see is see it from a surface point of view, we expect that if this double bond is very reactive, as alkenes are very reactive, they are extremely reactive. They undergo addition reaction very easily. The double bond breaks in, and then this double bond converts into a single bond, and the positions open on both the sides. So we expect the same kind of a thing happening in arenes as well, but it does not happen. Arenes are not much reactive. In fact, they are less reactive. So we need to understand why. And the answer to this question is they are less reactive because they are more stable. And why are they more stable? Because of the pi electron system that is in between them, among them. It brings the stability in different ways, and we will understand what those ways are. Okay, so the next thing is are the physical properties. That was all about the chemical properties. Now we'll be discussing what physical properties are. So as far as the physical properties are concerned, again, please put a star on it because you should better be learning it. So as far as physical properties are concerned, they have, we call them arene and we call them benzene as well. So they has van der Waals forces, van der Waals dispersion forces of attraction, between molecules. That's the first point. And the number 2 point is that it has a boiling point of 80 degrees centigrade. And what else we can say? Presence of non-polar hydrocarbon makes it insoluble in water. Insoluble in water. I hope you understand that in what there is a concept in chemistry which says like dissolves like, which means that the thing like dissolves like. So water is polar. So water will going to dissolve either an ionic compound or maybe a polar compound in it. So the ones which are non-polar, they can be dissolved into non-polar solvents, which generally are the organic solvents. All right. You can ask me for the further details on this concept, then I'll upload a lecture about that as well, but that's not directly included in the aerochemistry. So if even it says that, why benzene is not soluble, so you can see, maybe say a summarized kind of a concept that says benzene would have to break many hydrogen bonds between water molecule to be soluble in water. So the like dissolve like concept is not there in your A2 chemistry course, but the question comes and you can answer it in this way. So benzene would have to break a lot of hydrogen bonds between water molecules to get be soluble, to be a part of the water molecules, which does not happen. So this thing actually doesn't happen. And why doesn't happen? Because it's energetically unfavorable. A lot of energy is required. So yeah. So this is all about the arenes, a kind of an introduction as well. So this was the part 1. I would want you people to go towards the part 2, which is halogen arenes. Thank you so much for now.